This is 6.5 Linear Inequalities, page 394 in the text. The objective is to graph linear inequalities in two variables and to use linear inequalities when modeling real-world situations. For problem 1, we're going to identify solutions of a linear inequality. They're asking if the ordered pairs given for a and b are solutions of y greater than x minus 3. If the end result yields a true statement, it is a solution. If it is a false statement, it is not a solution. For problem 1a, my x component is 1 and my y component is 2. I'm going to put these values in for x and y of my inequality. 2 greater than 1 minus 3. When I simplify that, 2 greater than negative 2 is a true statement. Because it's a true statement, my answer is yes, because 1, 2 is a solution of the inequality. For part B, I'm going to put negative 3 in place of the x and negative 7 in place of the y. Negative 7 is greater than negative 3 minus 3. Because negative 7 greater than negative 6 is a false statement, my answer would be no. Negative 3, negative 7 is not a solution of the inequality y greater than x minus 3. Now press pause in the video and go to Nearpod and complete Got It Question 1. In problem 2, we're going to be graphing inequalities in two variables. The two examples that they give are y greater than 3 over 2x minus 1. It's important to note that each point on a dashed line is not a solution, and a dashed line is used for inequalities with greater than or less than. On the second one on the right, y is less than or equal to negative 3 over 2x plus 1. Each point on a solid line is a solution, and a solid line is used for inequalities with greater than equal to or less than equal to. My first step is going to be to graph the line in a y equals mx plus b mindset. The slope would be 1 over 1 because the number in front of my x is 1, and the y-intercept would be negative 2. So I'm going to start by putting a dot on y at negative 2 and then go up 1 and over 1 on my graph. I can also go down 1 and to the left 1 from negative 2 to continue my points. Because my equation or inequality has a less than or greater than symbol, my line is going to be dashed. If I had an inequality symbol of greater than equal to or less than or equal to, I would have a solid line, but I don't, so that's the reason why my line is dashed. Step 2, I'm going to pick a test point to test the side of my graph that's a solution. The easiest test point to pick is 0, 0. I can pick any point on either side of the graph, it just cannot be touching my line. 0, 0 is going to be our default test point because it's usually always the easiest one to test. On my graph, I've indicated where 0, 0 is located, and now I'm going to test for a solution. Plugging in 0 for both x and y, I have 0 is greater than 0 minus 2. The simplified inequality 0 greater than negative 2 is a true statement. The rule is if the test point side is true, you will shade on the test point side. If the test point side is false, you will shade on the opposite side of the line from the test point. Because 0, 0 is a true point, I'm going to shade everything on the side of that test point. The solution on the graph at the right is the final answer for y greater than x minus 2. Now press pause and try Got It Question number 2 in your Nearpod. Problem 3 is graphing a linear equality in one variable. What is the graph of each inequality in the coordinate plane? To begin my graph, I'm going to go to the x-axis and put a dot on negative 1. Because I have an inequality symbol greater than, I'm going to make a dashed line going above and below x at negative 1 because on this dashed line, all of my values are x at negative 1. Then I'm going to pick a test point on the x-axis. I'm going to pick the test point of 1. If I plug in 1 for x being greater than -1, that is a true statement. Because that is a true statement, I'm going to shade on the right side of that line because that is the side, the point, where x is 1 located. The second inequality, y is greater than or equal to 2. I'm now going to go to my y-axis and put a dot on positive 2. Because I have a greater than or equal to sign, I'm going to draw a solid line going out to the right and to the left because on this line, all points have a y of positive 2. Then for my test point, I'm going to do 0. If I put in 0 for y greater than or equal to 2, that is a false statement. Because that is a false statement, I'm going to shade the opposite side of the line, which would be above, that the point x0 is on. Now press pause in the video and go to Nearpod and complete Got It question number 3. This is problem 5, writing an inequality from a graph. Which inequality represents the graph at the right? Step 1 is to identify the slope and the y-intercept of the line. The line at the left crosses the y-axis at positive 1. The slope goes up 1, 2, and then over 1. So the slope of this line would be 2 over 1, or 2. Part 2, y equals mx plus b format, leaving space for the inequality. I'm going to write y, leaving a space where my equal sign would be for the inequality, my slope of m, which is 2, x, plus 1 for my y-intercept. Step 3, I'm going to use a test point to determine the direction of my sign. I want to pick a point in the green shaded area because that is where it is true. A point in the shaded area is 0, 0. If I use the point 0, 0, plugging it into my information above, I would have 0 space 2 times 0 plus 1. On the left, I would have 0. On the right, I would have 1. Because my point came from the true side of the solution, I need to make the inequality symbol so that 0 and 1 is a true statement. 1 is greater than or equal to 0. I have to use the equal to sign because I know I have a solid line. So my final symbol that would go between the information in part 2 is that y is less than or equal to 2x plus 1. Final answer, y is less than or equal to 2x plus 1. The correct choice would be A. Now press pause in the video and try Got It question number 5 in Nearpod.